It is generally not permissible to reuse the same service conduit when upgrading to a new electrical service. According to the National Electrical Code, Section 300.1b, electrical installations in all premises must conform to the requirements of this code. Also, Section 300.13 states that conductors entering enclosures or raceways must be protected from abrasion and other physical damage. There are several reasons behind this restriction. Firstly, the existing conduit may have sustained damage during the removal of the old service conductors. This damage, even if not immediately apparent, could compromise the conduit's integrity and its ability to protect the new conductors. Secondly, the conduit size might be inadequate for accommodating the new 200 amp service conductors. The increased current capacity necessitates larger conductors, and the existing conduit, originally sized for a 150 amp service, may not provide sufficient space. Overfilling a conduit can lead to overheating and potentially dangerous situations. Thirdly, the existing conduit may not meet the current code requirements for grounding and bonding. Grounding and bonding are crucial for electrical safety, providing a path for fault current to return to the source and trip a circuit breaker or fuse, thereby preventing electrical shock hazards. Newer codes may have stricter requirements for grounding and bonding than when the original conduit was installed. To ensure code compliance and safety, you must install a new service conduit that meets specific requirements. Firstly, size. The conduit must be large enough to accommodate the new service conductors, including the neutral and grounding conductors. The appropriate size is determined by the number and gauge of the conductors being installed, as specified in the NEC. Using conductor fill tables is essential to determine the correct conduit size. Secondly, material. The conduit must be of an approved material for outdoor use, such as rigid metal conduit or intermediate metal conduit. These materials are designed to withstand environmental factors such as moisture, sunlight, and physical impact. Thirdly, protection. The conduit must be protected from physical damage and moisture. This may involve using appropriate fittings and connectors, as well as ensuring that the conduit is properly supported and secured. Fourthly, grounding and bonding. The conduit must be properly grounded and bonded in accordance with the NEC. This typically involves connecting the conduit to the grounding electrode system of the building. Grounding ensures a low impedance path for fault currents, while bonding ensures that all metallic parts of the electrical system are at the same electrical potential, minimizing the risk of shock. It is generally best to install a new service conduit to ensure that the new service is safe and up to code. This proactive approach minimizes potential problems and ensures the long-term reliability and safety of the electrical system. Always consult with a qualified electrician and local electrical codes before performing any electrical work. Remember that electrical codes can vary depending on the location, so it is essential to comply with the specific regulations in your area.